All right, let's get started. Hi everyone, and thank you for joining this talk. My name is Pavlo, and today I would like to talk about how to automatically migrate Android applications to Bazel and make this process smooth. So a few words about me. I work on mobile infrastructure team at Lyft. Previously I'd worked at Grab, which is a ride-hailing service in Southeast Asia, which is kind of also like a super app where we were migrating primary mobile applications from Gradle to Bazel. Also, I'm a Google developer expert for Android, and overall having around 6 years of Android development experience. Okay, so about the agenda of this talk. First, we will talk briefly about what Bazel is, for those folks who are not familiar with it. Then we will take a look how to create a simple Gradle plugin that can do the automation from Gradle to Bazel. And finally, we will take a brief look at how to create a Kotlin DSL that will make the migration process smoother by generating some Bazel scripts in a nice way. Okay, so what Bazel is? As you know, when we are creating Android project by default, it uses Gradle as a build system. So similarly to Gradle, Bazel is also a build system, which was developed by Google some time ago. It was first internal project, but then at some point they open sourced it. So one of the cool features about Bazel is that this is actually a polyglot build system, meaning that it can build many programming languages and support many platforms, such as like Android, iOS, languages like C++, Python, and many others. And moreover, it's relatively easy to extend Bazel to support even more platforms and languages. So it's pretty useful to have it as a primary build system in the organization for many purposes. And also, initially, Bazel was built with a granularity in mind, because it was built in Google, where they have the large monorepository with all their code. And the main idea here is that instead of having large monolithic modules, you would rather have small granular targets, which has like short parts of code. And when you build the project, only those short parts of code will be rebuilt, and which is actually empowers the incremental builds and make them more fast and efficient, which is very crucial in large monorepository projects. And also, one more important thing is that it has a nice feature, which is like remote build cache and remote execution. This is a pretty useful thing on a large project, because instead of building everything locally on your machine, it's possible to generate the build cache, for example, on CI from master branch, and every engineer in the organization can just reuse it and locally rebuild only those parts of code that were actually changed. And with remote execution, the situation is pretty similar. So basically, instead of building everything on one machine, it's possible to distribute the efforts to build the project, which also speeds up the build speed. And last but not least, it has one more interesting feature, which is very useful. It's a query language. So basically, it's possible to natively write some queries to your project's build configuration, and then, for example, filter out build targets by some query filters that you would like to have. And basically, then you will have back the list of targets that comply with your requirements. And for example, on top of that, you can build pretty powerful tooling where you can create different queries for different purposes and create, for example, separate CI jobs that will build only those modules that were got back by the query result. Okay, so what is it like to work with Bazel? Because most Android engineers got used to work with Gradle, so let's take a look how it's different to work with Bazel. First, let's take a look at simple Gradle script, which is like pretty default one, nothing special here. It doesn't matter like the details in terms of code, but basically we have a plugin section, we have some Android DSL that does some Android configuration, and also we have a dependency section, which is like also pretty important to have. And okay, now let's take a look how the pretty similar configuration would look at Bazel. So here it is. It kind of looks similar, but first thing that we might notice that it uses a different language. As you know, Gradle uses Groovy and Kotlin scripts for writing the DSL and configuration. Bazel, in turn, uses Starlark language. And the Starlark language is a dialect of Python that has some intentional restrictions that were intentionally made to make sure that builds are deterministic. Basically, the main point with having the fully general purpose language as a build configuration language, it might bring some problems. For example, if you have an I/O, or if you, for example, can get the current timestamp during some build configurations, it may bring some problems that in similar circumstances on multiple machines, if you get the timestamp on 2 machines, the timestamp will be different. And if this timestamp is used during the build process, basically the cache and incrementality will not work. And sometimes it's easy to break this process and not even notice that. Therefore, Starlark specifically restricts such things and makes builds more deterministic. So let's take a look at details about the script. So first that we can see is a load statement. Pretty new thing comparing to Python, but basically this is an import statement. So as we just see before, Bazel is a polyglot build system, meaning that it can support and build code for different programming languages. So here we need to actually tell the Bazel which language do we want to build so that it knows how to do it. And here we're just doing the following thing. First argument in this statement or function, this is basically a file and source where we are getting support for this or that language. In this context, it doesn't matter where it's located, but it's some file which is called Kotlin.bzl. And from this file, we are loading Kotlin KT Android library function. In terms of Bazel, this function is called build rule, but its purpose is basically it knows how to build specifically Android project that specifically uses Kotlin language. And let's talk briefly about what it consists of. So first we are giving it a unique name, then some list of source files, some custom package as we do in Gradle. Also we are specifying path to manifest file, for example, resource files, and of course we need dependencies. In this way we are specifying dependencies pretty similar in a similar way. So we can specify either external dependencies, which are like third-party libraries and artifacts, and also we can specify internal dependencies like other modules in our project. Okay, so since we are talking about migration, let's clarify at the beginning, what does the migration mean? So what is the end goal of this process and what do we want to have as a result? So if you have a large Android project that consists of hundreds or maybe thousands of modules, each of those modules would have some build.gradle files or build.gradle.kts files. The end goal is to make sure that for each of those build.gradle files, we will create similar build.bazel files, which in turn internally would have all the configuration and scripts that will allow to build the same modules but with Bazel. And as a result, from the situation where we would build the project with Gradle wrapper, like assemble debug, for example, after doing the migration, we can run another command on the same project, which is Bazel build an app, for example. And the goal is here so that we can build kind of the project with 2 build systems. But eventually we will abandon the first one if our end goal is to build the project with Bazel. Okay, so again, if we have large project that consists of hundreds or even thousands of modules, it would be pretty hard to do it manually because the migration process does not happen overnight. So it's not that you just add a bunch of files and that's it. Usually you need to figure out how to build this or that use case, these modules. And moreover, that during this migration process, other engineers in your organization would likely modify already existing Gradle files. So it's important to keep all the things up to date and not going back to them. And to do this, we need just to transform the Gradle configuration of our Gradle project and just move the same, replicate it with Bazel. And the easiest way to do is just to write a custom Gradle plugin. So what we need to create? First, it will be we'll create a Gradle plugin, and this will be represented with a simple Kotlin class. Then for this Gradle plugin, we'll create a separate task, which will have all the functionality for the migration. And basically, this task will allow us to run this command, for example, in terminal, Gradle migrate to Bazel. And as a result, we will just generate a bunch of Bazel files. And finally, we also need to create a bunch of Bazel file templates. So we'll talk about it like in a minute. So okay, we are talking about Gradle task, which is like the body of our whole migration, and let's talk about what it should do. So since we're having like large amount of modules in our project, for each project module, we would do the following. First, we need to get the list of dependencies for each module, because we need to replicate the same dependency graph from Gradle to Bazel. And this also includes external and internal libraries and dependencies. Next, we need to determine which type of module is it. What do I mean by this? So we just seen the example script of Bazel, right, in Starlog language, where we are using KT Android library build rule to build the code. However, most likely, even though our project consists of like hundreds, thousands of modules, logically they can be split into some small group of categories. So for example, we have a bunch of modules which are Android modules. And then we can have another bunch of modules which are pure Java Android modules, and they are not using Kotlin. And for this, for all of those group of modules, we will be using Android library build rule. Similarly to just pure Kotlin library, where we can use another rule, which is KT JVM library. And similarly, for example, pure Java library module, which will be like represented with the Java library build rule in order to build all the code. And this list of categories, it's like not finite. It's up to the engineer, like how to do it. But basically, the idea is that we are reducing the complexity of the task just to a simple, finite number of categories so that we can work with it a bit easier. And finally, when we determined which category is this, and we just like agreed that the script for each category will be pretty similar, right? So if it's KT Android library, the structure of the script will be pretty similar, just details will be different. So for each of those categories, we can just create a bunch of Bazel file templates, which will just be the body of the script and of the code that we need to generate. And we'll take a look at them in more details just in a minute. Okay, so Gradle plugins is a fun thing, and we will definitely need to see like how to write them. And we will start with a simple project, which consists of like 2 screens. Yeah, this is definitely the type of project that would require Bazel migration, but still, this is just like for a simple example. And yeah, so what do we need to write? First, we need to create a plugin, which is a Gradle plugin. And to do it, we need to use Gradle API that is provided for us. We need to implement the plugin interface and implement the apply function. In this apply function, we can just register our task that will do all the heavy work for us. We'll have a separate class for that, and we can give it a unique name for this task. So we can take this migrate to Bazel name, and basically this will be the name that we'll need to write in the console, in the terminal, if we want to migrate the project. Okay, so now we have a migrate to Bazel task. We can again use the Gradle API for that. This one is pretty similar, just like for an example, we're just extending default task. And then we have a migrate to Bazel function, which is annotated with task action. And basically, this will be just an entry point for this task when you run it from a terminal. And now let's take a look at some demo. And instead of looking at slides, let's see how it works in code. So, okay, looks good. So we have this simple project. The structure is pretty simple. We have an app module, and it consists of like feed with the images, if you remember, and like details, like detail of specific image. Nothing fancy here, doesn't matter to be honest. It's one module, and another module we have images, where it's just a data layer for our application, which just like fetches images and like knows where to get them. Okay, so we have this project and we want to migrate it. Where do we need to start from? So if you remember, we have seen like some Gradle plugin classes, some like Gradle APIs, so where do we need to write it? We definitely shouldn't write it in like application module because it doesn't know anything about Gradle. We need to write the code in the area that will be executed by Gradle like during building the project. There are many ways to do it, but the easiest way would be just to use a build src directory. So it's a kind of a Gradle knows that this is a special type of directory. So if you just name it build src and you write code there, it will be like similar to any other module in Gradle, but the code that is in there will be executed by the Gradle configuration during building the project. So we can open sources, right? And here we have this migration plugin. Okay, so simple plugin, as we just seen, migration plugin. We implement plugin interface, and we add some migrate to Bazel task. And let's take a look what is migrate to Bazel task. What does it do? So as we've seen, this is a default task. So ignore this for now. We have a bunch of commented things here, and we will be unfolding them while we're going through this file. So we have this migrate to Bazel function, which is entry point to our task. And when we write migrate to Bazel command in the terminal, it will be run. So when using Gradle API, what we can do is we can basically get all projects. So all projects mean in Gradle, it's a bit confusing, but the project term in Gradle means actually module. So not the entire project, but it is the object that represents particular module. So basically we are taking the list of modules, as we just discussed. So for each of those modules, we need to perform some action. And this action will be a migrate module function, which we have defined over here. Okay, so what do we need to do inside this function? Again, next thing that we need to do is to determine the dependencies of each module. And we will have them as mutable list. This one will be artifact dependencies, and this one will be module dependencies, basically internal and external dependencies. And now we need to get the list of those dependencies. So what would we do? It's a weird selection, but okay, should be fine. Yeah, so again, the project is object that represents our module, and we need to take the list of configurations. What is configuration is? So if we go to any module in our application, for example, build.gradle, right? You can see this implementation, KAPT, test implementation. So these words, this thing in Gradle, this is called configuration. So basically it determines the way how do you specify some dependency, for example. And here what we need to do, we are taking the list of all possible applied configurations to this module, and we filter it because we need to select only those dependencies that are marked with certain types of configurations. We can see it highlighted in red. If we go on top, we have this list defined here. So basically what we will take here, we'll just select only those dependencies that are marked with implementation or API configurations. So basically those dependencies and modules and artifacts that are defined with those words in our Gradle scripts. So then after filtering out, we just taking the list of all dependencies that are marked with those two selected configurations. And here we're just having simple when statement. And this is again objects from Gradle API, but basically what we can do is to identify whether it's external or project dependencies. External is artifact, third-party library, and internal is another module that we are depending on. And to not getting into details of this code, we are just representing each module with a string, and we're just appending the string to the artifact dependencies which we have here. This is a list of strings. And similarly, we are doing representation of this module as a string by Bazel rules, to have a label that will be recognized by Bazel. And we're adding it to module dependencies. So now that we collected all the dependencies, we can go next and do the following. These two functions, they just do a simple job. They convert the list of strings into the string. So since our end goal is to generate some code, so basically we need to prepare some strings that will represent the content of files that we generated. So yeah, again, just simple string transformation, and at the end of the day, both of those variables will contain contents such as this. So it will be a multi-line string, for example, with multiple dependencies specified here. And then we are moving to the next step. If you remember, we've discussed that we need to determine which type of modules is it. Is it like Java module or Android module? And like we need to categorize our current module. And how to do it with Gradle? We can apply many approaches, but the easiest one would be just to take a look what plugin is applied here. So for example, if you are going to check our images module in the project, if you open build.gradle file, we can see that it has a bunch of plugins applied. So those plugins are pretty similar to Bazel rules that we are loading to support building different languages. So in this case, if it's com Android library, this is a definitely library. And for example, if it has Kotlin word, then it will support Kotlin. And by checking the bunch of those plugins that are applied to this module, we can determine its type. So if we're going back to our script, Gradle API has this function has plugin, and you just check it by its ID, and it returns true if this plugin is actually applied. And basically, we are now categorizing those modules, and for example, this is an Android library module. So what do we do next? We've discussed earlier that we need to use templates so that we can generate code for the modules from those templates. So if we go to this file, so it's defined in the same module. For example, Android library template. This is just a regular function that returns a string, but it uses string interpolation so that it uses the same structure for each Android library module, but the details about each module will be obviously differently because we have different names, package names, and dependencies. And basically, we're just inserting all the data that we found out during the previous steps, like what is the package name. We also can find it out from the Gradle. For example, if you go back here, we can just project, get package name. I think this is a custom function, but I mean, it's pretty simple. Project name, for example, etc., and artifacts. The artifacts that we just generated as a string, for example, here. And basically, we're just modifying this string. And again, so we've run this step. We determined what is the type of this module, and we returned its content. So we return string that represents the content of this file. And then what we can do just simply, we can create a file, just regular Java file. We can give it the path of the module that we are working with. It's highlighted in red, but it's for some reason some issue with Android Studio, so it should work fine. So basically, we're determining where to put this file, and we just give it a name, build.bazel. Then we're just creating this file, and we are writing the text to this file. So pretty similar. It's pretty simple, kind of. Here are like some additional functions. They are needed to generate some Bazel files that are not related to specific modules. So for example, in the Bazel you need to have a workspace file, which will be a single file per your repository, per your project, and it should be in the root directory of your project. And it has some additional configurations, but basically you might generate some additional files here. So now we created like this pretty simple plugin, and what we can do now, I'll exit the presentation mode here. I hope so, yep. And let's open the terminal. And yeah, and final thing before we do it, we just need to go to the build.gradle file root file, and since we created our migration plugin, we need to apply it to our project. So usually we apply plugins with the ID, for example, apply com Android like library, but since we have this class in our project, we can do it this way and just apply it directly. So after we are doing it, we can run the migrate to Bazel command. I'm not sure if it's visible enough, good enough, but basically we're writing Gradle wrapper, migrate to Bazel, the task that we created to migrate the project. We can run it. It will think for some time. Yeah, it was cached for me, so it was quick, but it will take like a couple of seconds. So now what we can see is that we have a couple of new files created in our project. So we have this images module where we have build.bazel file, and we have the application module where we have build.bazel file, and what we can do, we can go to the images, and here is the build.bazel file that we just generated. So it's pretty similar to the string that we've used, right? And it just pasted name in the correct place. It pasted package name, and also it's inserted a list of dependencies that we have. And if we can compare it with the initial template, for example, yeah, here. So basically, this is the file that was used as a source. And then what we can do, we can now write Bazel build application. So I'm using Baselisk. This is a tool which serves as a wrapper for Bazel, similarly as like Gradle wrapper. But basically, what we can do, now we are running this project with Bazel. And here we have built completed successfully. So yeah. So just to prove that this works as it works, I can do some things here. For example, in this script, I will write some random text. And for example, when we run the migration, so it will regenerate all the scripts now. Okay, it's done. Then we go to this file and we see that this thing was inserted here. And basically, it's very convenient because every time that somebody changes the Gradle configuration of your project, you can just rerun this command, or you can run it like on CI and it will just redo all the work. Okay, so let's get back to slides. Yeah, I mean, it all looks great when you have a project that consists of 2 modules, and overall in real life it works a bit different, but the point here was just to demonstrate the idea, which will be the same for any type of project. So basically, the problem that might come up is, first, it's iterative process. Since we have multiple categories of modules, we need different build rules to build those modules. And usually you won't migrate all the project. First you will select one type of modules, just figure out how to build them with Bazel, then migrate it. Then we move further to another types of modules. And with some modules, you might have some complications. For example, if you're using some third-party, some sophisticated Gradle plugins, some custom things, since they are Gradle plugins, they cannot be applied to Bazel. So in some cases, you would need to write your custom rules to support those functionalities, or like hope that somebody wrote an open source solution for it. And basically, the community of Bazel open source stuff grows pretty fast, but obviously there might be things that are not present yet there. And also there might be edge cases. So I had a fun use case. Basically, when we were migrating the project at grep, we were using this library that in the manifest file of which the package name was represented by a single word. So instead of like com.packagename.library name, it was just library name. And Bazel refused to build this library like intentionally because the error message was you need to have at least one dot in the package name of this library. I mean, so such weird thing happens and you need to be ready for that. So yeah, and another thing was that using data binding, for example, data binding is not fully supported by Bazel. I mean, I don't think somebody would need to use data binding like at this moment where we have Jetpack Compose, but different things happen. And yeah, it also brings some complications because you need to write additional rules to support data binding. Okay, now that we've seen like the general approach for the migration, I want to emphasize one thing specifically that related to the code generation of Bazel scripts when we're doing the migration. So as you remember, we have this like simple function that generates some scripts. I mean, for such small scripts, it might be fine. Just use string, but in some cases we might have larger scripts, and I mean it's not type safe. It doesn't have code highlighting, and especially when you're just like learning Bazel, you can just like forget about some comma or like don't remember like the name of such things, or like the syntax might be confusing. So instead, what can be done? There can be created a DSL in Kotlin that can mimic all the syntactic constructions and functions that Bazel has, and made this process like type safe because, for example, when we specify the name of the library, that should be a string and not anything else. And secondly, we will have just a set of libraries and set of rules that present in Bazel with the correct number and set of arguments, because each build rule in Bazel has different set of properties and arguments. So in order to do it, what we can do is that since Bazel files are called build.bazel, we can create function in Kotlin which will open the curly braces, and inside those curly braces we would see, we would write the content of generated build files. So further, I will show a couple of snippets, just like for the notation. When I will show first Starlark snippets, which will have like Bazel logo, and then I will show DSL, which can generate those Starlark snippets, and they will have Kotlin logo in it. So let's start with the simplest statement. We had a load statement, right? We need to create a DSL that eventually will generate the load statement. So we can have a DSL for that, which we can create a simple function load, which, I mean, this is the simplest case because this looks exactly the same as Starlark looks. So it's kind of a declarative approach for generating scripts. Okay, let's take a look at something more complex. For example, variable assignment. So sometimes in scripts we just need to define variables and like somehow use them. So for example, we can have string variables, list variables, and dictionary variables. So in order to generate it in Bazel, we can do something like this. We can define just name, and we can use delegation operator by application. So why do we need to use by and not just like assignment statement? Because if we just use assignment statement, we will just assign the value to the variable in Kotlin. I mean, we don't need to do this assignment in Kotlin. We don't need to use the name variable in Kotlin, but we need to generate this assignment in the eventual Bazel file. So we can use operator by, and like under the hood, we can just implement like the way how we want to generate it. Similarly to list, for example, we can just use simple function list. We can override this like a get ID operator and just define some DSL for this. And similarly with a dictionary, we can define dictionaries that will eventually generate assignment for dictionaries in Starlark. Okay, next thing is concatenation. So sometimes you want to generate not just like variable assignments, but you need to assign, for example, source files for some target from different sources. One variable will contain one part of files, another will contain another part of files. And we actually need to have a way to generate this plus operator in Starlark. So in order to do it, we can use this construct, and we can use this plus function, but with backticks. So why do we need to backticks? Because this is just a regular function. So again, instead of like combining two lists in Kotlin, we need to generate this plus in Starlark, and that's why we are doing it. And moreover, since we're using Kotlin, we can specify the type, which is, for example, we want to have only lists. So instead of generating some code that doesn't work and then only verifying it in Starlark that something is not building, we can have more validations on the Kotlin level. And for example, when writing code in Kotlin, the IDE will tell us like that something is wrong. So in this case, we will have a compilation error because, for example, in Python or in Starlark, you cannot add string to the list of strings with this operator. And this will be the same in Kotlin. So again, another cool feature of Starlark and Python is a list comprehensions. So basically, this is a like simple list builders where you have like three parts. We have basically what it does is like for each item in the list, it will perform some expression, and it will return like a new item that will be a part of the new generated list. We can have a similar DSL in Kotlin for that. So for each item, we can like give it a name, and this name will be generated in code. So that's why we're using this string here in the list. And basically, the list is a variable that we just like assigned value to it earlier, and it will preserve the type. So if it's a list of strings, this thing will know that this take expression will know that this argument is a string. So the types will be preserved here, and eventually when we generate the scripts from this DSL, the list comprehension will be generated. And like finally, similarly to what we just seen in the first script where we're using build rules, we can just define simple functions, set of functions that will generate those build targets in StyleArc. And what's important is that, for example, we can have, as we mentioned, we can have sources variable that has one part of files, and then we can just like concatenate another list to it. And in order to generate it, we can have the list assignment operation, and then use this concatenation plus with backticks to perform this. And basically, it will generate this, again, this plus operation. Again, like if we're considering like for simple like scripts, it might be, might seem useless, but in Bazel you can create like more complex scripts for your modules. And for example, here's the script from a real world where it consists of multiple components. So first, we need to just assign the list of files to the file, and then we have an interesting thing. So we're using list comprehension, and where for each file in this list of files, we actually declare a build target, which uses a general build rule. So general is just a generic thing from Bazel that allows you to generate some code, some files, do some like arbitrary work. Again, we have the name which consists of multiple components. We have a concatenation. We have those like slice operators, like lists. We have the plus operator again with concatenations, some other arguments. And then, for example, if you see like this general, it has modify imports in and like some argument. And basically, we have another list comprehension that triggers this general for each file in the list of files and actually returns, so the up files variable will hold the list of items that were generated by this general. Like, so pretty complicated, but this is just like the case to show that this DSL can be scaled to such more complex cases. And eventually, we can do it this way with the DSL. So we have our function where we can put some arguments, for example, specific package name for the module, or like module name, or something like that. And we are using, again, list comprehension here, the way we've generated it, the way we've used it before. So if you can see this file argument in the Lambda, it will not be just like any variable. It will be a variable of type string, because view models with res imports this like list. It's a list of strings where each string represents the file name. And basically, it helps to preserve a type safety of the whole construction. And you will have much more compilation validations during like writing this DSL, instead of like finding out that something is wrong when you just generated the resulting script. And again, another list comprehension that we have at the bottom here. Okay, so to conclude, yeah, we just like considered like simple Gradle plugin that shows the overall algorithm how to migrate the projects from Gradle to Bazel, and definitely it can be extended if you apply it to large projects, like to scale to different types of modules. Yeah, but the idea will be pretty the same. Yeah, and like using this DSL, it showed like in practice that it's much more convenient when you have this code highlighting, you have IDE support with all the generated functions and all the stuff, which makes things much easier. And yeah, and finally, if you would like to check the project that we just considered like in this talk, you can find it on GitHub. And also, if you're interested about the DSL and like take a look how it works, we can check the project called Irene. Basically, this is a tool I'm working on for automatic migration to Bazel. So basically, it has this component of code generation, like its template engine, which basically creates an abstract syntax tree from this DSL that we just seen, and based on that, it generates formatted code in StyleArc for the scripts when we are generating them. So that's pretty much it. Thank you. Thank you.